This is question 12, paper 2 from the SQA Specimen Paper for National 5 Mathematics. We're asked to find the range of values of this coefficient of x squared, p, so that this equation has no real roots. Well, let's give a wee bit of background to this. You know that solving any quadratic equation, ax squared plus bx plus c equals 0, in the normal course of events, you get two solutions or two roots to this equation. One of them will be minus b plus the square root of b squared minus 4ac all over 2a. And the other one is minus b minus the square root of b squared minus 4ac all over 2a. So two solutions. Now this number that's under the square root sign, b squared minus 4ac, let's call it d. Let's give it a big capital D. If d is greater than 0, let's look at that case, then we've got minus b plus the square root of a good healthy positive number. Suppose it was 9, you get minus b plus square root of 9, which is 3. You get minus b plus 3 all over 2a, and you get minus b minus 3 all over 2a. You'd certainly get two solutions, two different values for x. So if the thing under the square root sign, this discriminant number, is positive, then you will definitely get two solutions. They'll be different, be normal, real numbers. On the other hand, if that thing under the number under the square root sign, the discriminant, is equal to 0, then look what happens. Your first solution is negative b plus 0, square root of 0 is 0, negative b plus 0 over 2a. Your second solution is minus b minus 0 over 2a. They're the same. If you add 0 and subtract 0, it doesn't make any difference. So in effect, you're not getting two solutions, you're getting only one solution. You'll hear people talk about the solutions are equal, the roots are equal, but there's basically only one value that you get. Now the third case that might happen is you work out all this and you discover that the number under the square root sign is negative. Now you'd be hard pushed finding the square root of a negative number. It's certainly not real. Now that word real is a very special mathematical word, and we're talking basically about all the numbers that correspond to any point on this number line. There's 0, there's 1. Any point on this number line will correspond to a real number. So we're talking about square root of a negative number not being on that real number line. In other words, there are no solutions, not among the real numbers, for this equation. So if the discriminant, the number under the square root sign, is negative, we've got great difficulties. There are no real solutions. So remember that the discriminant is b squared minus 4ac. That's called the discriminant. It discriminates between these three different situations that arise. Two solutions, one solution, no real solutions. So with that in mind, let's have a look at the equation we're asked to solve. Px squared minus 2x plus 3 equals 0. And to determine if there's two solutions, one solution, or no real solutions, we'll have a look at the discriminant. So for this equation, the one that's been given to us, the discriminant is equal to, now b squared is the coefficient of x. It's the number in front of the x, which includes the negative. So it's b squared minus 4 times a, coefficient of x squared, that happens to be p, ac. C is the constant term at the end, which is positive 3. So it's 4 times p times 3. b squared minus 4ac. Negative 2 squared, negative 2 times negative 2 is 4. 3 4s are 12 times p. 4 minus 12p. Now it says find the range of values of p so that that equation has no real roots. So we're in this situation down here where we want no real roots. And that's the case where the number under the square root sign, the discriminant, is less than 0. So we would write this down as for no real roots, we must make that discriminant, we set the discriminant less than 0. So we want 4 minus 12p to be less than 0. So let's solve this inequation. First of all, let's add 12p to both sides. We get 12p over here. Let's divide both sides by 12, positive 12. So there's no problem, that less than sign still stays as a less than sign. We do a bit of cancelling here. 4 into 4 goes 1, 4 into 12 goes 3. We cancel the factor 4 from top and bottom of this fraction. So we're getting very close to the answer. We know now that 1/3 is less than all the values that were allowed, or putting it a more sensible way, all the values that were allowed are greater than 1/3. So that's the required range of values. So p can be any real number greater than 1/3. If that's the case, then this equation cannot be solved, in the sense you will not get real valued solutions to this equation.